I'm your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So we are doing special cases that arises in the simplex method, and today we are going to see an unbound solution. So in the previous lectures where we have studied the graphical method, we have seen how unbounded solution can be identified in a graphical method. There we understood that the unbounded solution possesses two things. First is that it has an unbounded feasible region, and simultaneously it has an unbounded value of objective function, that is the value of z. So if both these conditions are satisfied, we can understand that our solution is an unbound solution. But in case of simplex, how can we identify an unbound solution? So in simplex method, unbound solution occurs when we are unable to find the leaving variable on the simplex matrix, and this happens because in our key row we selected, we have all the variables as 0 or negative, and because of that we will have the minimum replacement ratio, which is also known as theta, minimum replacement ratio, as negative or infinity. And we know that both these values of theta are ineligible to participate for the leaving variable. So it shows that we have an unbounded region in that particular section. So let us understand this with the help of a problem. So let us start. The problem is given as maximize z is equals to 4x1 plus x2 plus x3 plus 3x3 plus 5x4, subject to constraints 4x1 minus 6x2 minus 5x3 minus 4x4 greater than equal to minus 20, minus 3x1 minus 2x2 plus 4x3 plus x4 less than equal to 10, minus 8x1 minus 3x2 plus 3x3 plus 2x4 less than equal to 20, and x1, x2, x3, x4 should be greater than equal to 0. So first of all we will convert this into standard form, and before converting into standard form we must ensure that the right hand side values of the constraint must be non-negative. So here in the first constraint we can see that the right hand side value is negative. So what we will do is we will multiply this equation with minus 1, and simultaneously we will reverse the sign of inequality. So here our constraint changes form as minus 4x1 plus 6x2 plus 5x3 plus 4x4 less than equals to 20. So now we have all the three constraints with right hand side value as non-negative. Now we can convert this into standard form. So let us do it. Maximize z is equals to 4x1 plus x2 plus 3x3 plus 5x4, subject to constraints. This will be minus 4x1 plus 6x2 plus 5x3 plus 4x4. This is less than equal to, that means we need to add a slack variable to make it equal to 20. So we will add a value as 1 is equals to 20. Now the second equation, minus 3 x1 minus 2 x2 plus 4 x3 plus x4, and here also we have less than equal to sign. So to make it equality we must add a slack variable here. So this will be s2 is equals to 10, and the third equation, that is minus 8x1 minus 3x2 plus 3x3 plus 2x4 Here also we have less than equal to sign, that means we are going to add a slack variable here also. So plus S3 is equals to 20, and x1 comma x2 comma x3 comma x4 comma s1 comma s2 comma s3 all should be greater than equal to 0. So now we have converted this problem into standard form, and we must show here slack variable takes the 0 coefficient in objective function S3. Okay, so now let us start solving and write the initial basic feasible solution. So we have the variables as x1, x2, x3, x4, s1, s2 and s3. Objective function coefficient as 4, 1, 3, 5, 0, 0 and 0. Now in the first constraint, if we put x1, x2, x3, x4 equal to 0, we will have s1 is equals to 20. So s1 can enter the basis. Similarly, in the second constraint, if we put x1, x2, x3, x4 equal to 0, we will get x1 equal to s2 equal to 10, which makes it eligible to enter the basis column. Similarly, in the equation 3, if we put x1, x2, x3, x4 equal to 0, we will get s3 equal to 20, and which makes s3 eligible to enter the basis column. Now let us write the constraints coefficient here, which is -4, 6, 5, 4, 1, 0, 0 equals to 20. Second is -3, -2, +4, +1, 0, 1, 0 equals to 10. The third equation, -8, -3, +3, +2, 0, 0, 1, sorry it is 1, this will be 1 equal to 20. Now to check the optimality here, we must calculate the value of Cj minus Zj. So here Cj, as these three are 0, the value of Zj will be 0. So Cj minus Zj will come as 4 minus 0 is 4, 1 minus 0 is 1, 3 minus 0 is 3, 5 minus 0 is 5, and S1, S2, S3 are having value 0 because they are in the basis column, and the value of objective function will come as 0. Now we need to find the maximum positive value in Cj minus Zj row. So here we can see that among these 5 is the maximum positive value, so we will select this as our key column, and this decides our entering variable, which is x4. Now we can see that to find out the leaving variable, we need to calculate the theta, which is right hand side value divided by corresponding key column element. So here we can see 20 divided by 4, which is equals to 5, 10 divided by 1, it is 10, 20 divided by 2, it is 10. So we need to select the minimum positive value here. So 5 is the minimum positive value available, and this will be our pivot row. This shows that variable S1 will leave the basis and it will be replaced by variable x4. So this is x4, this is s2, this is s3, this will have equation 5, this is 0, this is 0. Now we have our pivot element here as 4, and we need to make this value as 1 and the remaining values in the column as 0. So what I'll do is I'll divide this first equation or first row by 4. So this will be -1, this will be 3/2, this will be 5/4, this will be 1, this will be 1/4, this will be 0, 0 and 5. Similarly, I need to make this as 0. So what I'll do is row 2 minus of new row 1. So 3 minus of -1 means +1. So -3 plus 1 is -2. So -2 minus of 3/2. -2 minus of 3/2, that is -7/2. Okay. Then 4 minus 5/4. So this will be minus, or I should say 11/4. 4 4 16 minus 5. Okay, 11/4. This will be 0. This will be 0. Minus 1/4 is -1/4. This will be 1 minus 0 is 1. This is 0 minus 0 is 0. Now 10 minus of 5 is 5. And if I need to make this as 0, I'll take row 3 minus of 2 times of new row 1. So -8 minus of -2 is +2. This will be -6. Similarly here -3, this will be multiplied by 2, so it is -7. So -3 plus 7 is equals to +4. I should write 4 only. Okay, then 3, and that's 2 times 11/2. 3 minus of 11/2, that means 11 minus 6, 5/2. This will be minus 5/2. This will come as 0. This will be 0 minus 1/2 times. Sorry, it is 2 times of this into 2 is sorry, there is a calculation mistake, I guess. This will be -3 minus of 2 times of this. So this will be this minus 2 times of this row. Okay, so -3 minus of 3, this will be -6. This will be 3 minus of into 2 times 5/2. Okay, 5/2. This will be 1/3. This is 2.5, so this will be 1/2. This is 0. This is 0. 1/2. 2 times will be -1/2. This will be 0. 0 minus 2 times of 0. 1 minus 2 times of 0 is 1. And 20 minus 2 times of 5 is 10. 20 minus 10 is 10. Now, so we have calculated this matrix, and now we need to calculate Cj minus Zj to find out the optimality. So this will be minus of -5. 4 minus of -5 is +5, so this will be 9. And this will be 15/2. 1 minus 15/2. So this will become minus 13/2. Similarly, we have 5 into 25/4 is 12. This will be minus 13/4. And these are the basic variables. x4, s2 and s3 are basic variables, and they will take the value as 0 and this will be 5 by 4. So 0 minus 5 by 4 is minus 5 by 4. So now as we can see here that in the Cj minus Zj column we have one positive value which is 9. So 9 will be our key column, and this indicates that variable x1 will now enter the basis, and to find out the leaving variable we need to calculate the value of theta. And once we are going to calculate the value, we can see that the right hand side value divided by corresponding key column element, and we notice that each value in the key column is coming as negative. That means either 5 by minus 1, 5 by minus 2 or 10 by minus x, we will have a negative ratio for which we use dash sign. That means all these three variables are not eligible to take part in the leaving variable, and this shows that our problem has an unbound solution. So to identify in a simplex method an unbound solution, we must identify that in the key column if we have all the variables as 0 or negative, if there is all the variables in the key column are either 0 or negative, then we will have no variable to participate in the leaving variable. So our problem will be unbounded solution. Now let us understand this. When we have studied the graphical method, we have seen and we have understand that if I draw a simple graph, and this is x1, this is x2, and let this be any constraint which has a feasible region away from the origin. And so here is the feasible region of this particular graph, and if we need to find the maximum value here, if our objective is to find the maximum value in this particular graph, what our simplex problem does is it will move from one corner point to the other corner point. So as we can see here, if we move to one corner point, let us say if we have moved till here, now after this, first is our initial basic feasible solution where we have 0 and 0 coordinates, that means x1 equal to 0 and x2 equal to 0, and after moving in any of the direction we can find that we does not have a next corner point which will give us a better solution to move ahead. In that particular case we can see that our problem is an unbound feasible region, and along with that the objective function, when we draw the objective function line, it will continuously increasing, that or we can say that the objective function will increase indefinitely. So we have seen this in the graphical problem, and simply to find out the unbounded solution in the simplex matrix, we need to find out that the leaving variable is able to be selected or not. As in this case, all the values in the key column are negative. That means we are unable to decide the leaving variable, and this shows that our problem is an example of an unbounded problem. Okay, so in the coming problem we'll do such more special cases that we can see in the simplex method. If you like the lecture, please share the lecture. Have a nice day. Thank you.